Reading and Interpreting Data, Unit Test Review. The graph shows the number of hurricanes that occurred over 4 months. So we see that this is a bar graph again. It's not a histogram, it's a bar graph. September is between 6 and 8, so September looks like it would be 7. August would be 4, and June would be 3 because it's between 2 and 4. There is no number for July. The number of hurricanes in September is blank. The number of hurricanes in June, July, and August. So we want to take a look at June, July, and August. So June, July, and August. August was at 4. July, of course, was 0 because there's no bar there. Let's see, the other one was June. June between 2 and 4 is 3. So we clearly see that that total number there would be 7. Now we're going to compare that to September. September's between 6 and 8, so September's also 7. So they're both 7, so if we took 7 minus 7 is 0, so they're the same numbers. So let's see what the possible choices would be. Well, they would be greater? No. They would be fewer? No. They're actually equal because they cancel each other out, so this would be equal to. Nam owns a used car lot. He checked the odometer of the cars and recorded how far they have driven. He then created both a histogram and a box plot to display the same type of data. So which display could be used to find how many vehicles had driven more than 200,000 kilometers? So again, if we look at the histogram, we can clearly see the 200,000 right here, and we can get an idea by looking at the top here that, oh yeah, this is 3, this is 2. Now again, with the box plot, you really don't get that kind of detail, so the histogram would actually be a better choice for determining how many vehicles have been driven over 200,000 kilometers. So that would be the histogram. Which display can be used to find the median? Now, so again, they're using one of the words here like median. They're looking for quartiles, words like that. Well, that would reference you more towards the box plot. So we want it to be 140,000. So if we look at this, this is the smallest number. This is the largest number. So that's the smallest, that's the largest. That's as far as it goes. This number that's truly in the middle, this line right here that sits exactly in the middle between everything, that's called your median, and it is at 140. And remember, this is based on thousands, so that 140 would actually be 140,000. And these other parts here, this is called quartiles. These are quartiles, and that's between the small and the median, and that's between the median and the larger of the numbers there. So those are called the quartiles. So again, they use the word median, so that tells me to go ahead and use the box plot for that. Karen picked apples at Carter's apple orchard this week, and she made a graph to show how many apples she picked. Now again, with these, they're fairly simple, but you got to make sure that you understand what the scale is. Each apple you see is a reference of 2. So she ate 5 Fujis. She ate 5 Fuji apples, because that's one of her type of apples. There's Fujis. And dropped 4 Gala apples. After Karen ate and dropped those apples, which two types have the same number of apples? So she ate 5 Fujis. So if she ate 5 Fuji apples, that would eliminate 2, 4, and this would give me about a half of an apple right there. So what we'd have left is 2, 4, 6, and then that half there, that would become 7. So that would be 7 apples there. Now, because she said Karen ate 5 of the Fujis and dropped 4 Gala apples. So she dropped 4 Gala apples. So remember, each apple is worth 2, so she's going to get rid of 4. So that means we want to eliminate these 2 right there, just like those were eliminated there. So what we have left is a whole apples. That's 2 and 1, so that would be a value of 3. This would be 2 and 1. That would also be a value of 3. This one would be 2 and this would be 2, 4, 5. So actually, these two right here would be 3 because we have one apple, and a half an apple, and both of those would be 3. So it looks like it's the Gala and the Granny Smith apples because we want to determine which ones are the same. So we want to go Gala and Granny Smith apples. Okay, now we have the following dot plot shows the number of songs on each album in Sal's collection. Each dot represents a different album. So how many albums are in his collection? So this right here is actually the number of songs. But see, if you look at the directions or instructions closely, what they're saying here is they're saying that each dot represents a different album. So we want to figure out what those albums are. So what we do is we simply count the dots. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So each dot there represented an album there. So it should be 17 albums. Okay, next one. Dorothy gives a ribbon to each of her friends in the following order and then starts over from the beginning. So we got Scarecrow, Tin Men, Cowardly Lion, and Toto. So we'll say S. We'll say TN for 10. We'll say CL, and then we'll say TO. So again, we can start this off 1, 2, 3, 4. So I predict that on the last column here, 4, we're going to be counting by 4s here. So watch what happens. So when I go around again, this is 5, 6, 7, 8. Do you see that? Then you go 9, 10, 11, 12. So you can see the building of the 4. So this next one's going to be 16. So right here we could go 13, 14, 15, 16, just like we predicted. So if we were going to go again, I know it's going to be 20, so we know we don't have to go again. So we'd go 17 and 18. But see, you could actually accelerate all this right here. You could, once you pick that number up, you could go 4, 8 and say, okay, well, 16, so 16 is here. So then we go 17, 18. So it's very easy if you determine what the last column is, that's what you want to count by. So this case here, we're counting by 4s, so I know immediately this is 16. Then I could have gone 17, 18 and said, oh, it's going to be the Tin Man. So let's click on this. Let's cut this off here. And let's go to the Tin Man. Okay, so now we want to look at, this is actually a histogram because again it's ranges on the bottom from 0 to 3, 3 to 6, 9 to 12, and 15, and so forth. How many pumpkins have a mass greater than 6 kilometers? Or not kilometers, but kilograms. So what you want to do is you want to make sure that you know that the mass is the bottom here. We don't want to be content with the number of pumpkins, it's the mass because we use the word mass here. So this is 6, so we want everything that's more than 6. So we want to go in this kind of direction. So this one is 8 right here, so that's 8. This is exactly at 6, so these are exactly at 6. This is exactly 8, and this one is exactly 2. So these actually fall on exact numbers here. So we have 2, we have 6, and we have 8. So what we do is we simply add these up together. So 8 plus 6 is 14. 14 plus 2 is 16. So altogether there would be 16 pumpkins more than 16 kilograms. Okay, Bailey Bear could not help himself and reached right into a beehive to get some honey. Ouch. Now he has bee stings all over. Create a bar graph to show how many bee stings he has on each leg and arm. Okay, so we want to make a bar graph here. So the first one up is the right arm. So we see that the right arm is a value of 10. So we're going to extend the bar graph with the right arm up to 10 and stop. So right there we're at 10 and we stop. Next one is right leg. Notice the right leg is at 2. So the right leg here is at 2 here. So let's extend this up to 2 and stop. Left arm. The left arm is at 8. So let's extend this up to 8 and stop. And then the left leg is at 4. We extend up and stop. So all these fell on exactly an exact number here, such as 2, such as 4, such as 8, and 10. So let's check it. Next one. Okay, a zookeeper published the following stem leaf plot showing the number of lizards of each major zoo. Now again, remember with the stem leaf, it's a quick way to arrange your numbers without being a full and complete number here. The zeros here, those are like your single numbers. The 1 is like your teens, like 11, 12, 13, 14. The 2 is like your numbers in the 20s. So this is 20, 26, 28, 28, and 28. So each one of those 8s represents 28. This is your 30, so that would be 30, 32, 36, 36, 37, 38. And this would be your 40 range. So we start with 41, 42, and then 46 and 46. There is no numbers with the 5 or the 6, and there's no number with the 1 and the zeros. And they tend to give you a scale here to 2 with the slash and the 0 here to remind you that to read that as 20. So what we want to do is figure out how many zoos have more than 26 lizards. So if we look at the graph here, we clearly see that this is 26. So it's got to be more than the 26. So we can't include the 26 itself. We want to be more than the 26. So what we do is we count all these numbers here. So 1, 2, 3, because of course those are 28s. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it appears to be 13 because we want numbers that are more than 26. So we don't want to use those numbers. We want to count all the other individual numbers. Okay, Carol created a chart and a bar graph to show how many of each vehicles were in her supermarket. So she has trucks were at 25, vans were at 5, cars were at 40, and SUVs were 10. We want to label each. So this one is a label problem here. So if we look at this, we clearly see that this one stops at 10. So let's go back and look at our graph and see, oh, okay, SUVs are at 10. So we click on this blue dot and we clearly see this was SUVs. If we want to check that, we click it and we say, okay, that is SUVs. So SUVs were 10. Now this next number is between 20 and 30. So between 20 and 30 is 25. So that's trucks. You can clearly see that's trucks there. So trucks is 25. So let's click here. Let's find the trucks. And we can click on it just to verify that what we clicked on. Now the green one goes all the way up to 40. So 40 was actually cars. So we click here, click on the cars, and we can again verify that and say, okay, yeah, that is correct, that is cars. And now the last one's between 0 and 10. So what's between 0 and 10? Well, that's clearly the vans. So the vans is between 0 and 10. So we click here, we find the vans, click on the vans. So now we're ready to check this.